Hello students, welcome to ePhysics. Students, in the previous two videos we have derived the equations of motions. In the first video we have derived the equations of motions algebraically. In the second video we have derived the equations of motions graphically. And here we will be discussing the equations of motion by the calculus method. Now, this calculus method is important for the class 11th pointer. Okay, now let's start with the first equation, derivation of the first equation from the calculus method. Students, from definition of acceleration of motion, we have been knowing from definition that acceleration is equals to rate of change of velocity, that acceleration is equals to dv upon dt. Now this can be written as a multiplied by dt is equals to dv. Now if we integrate both sides, students, now integrating both sides, so what do we get after integrating both sides? That is integration of a dt is equals to integration of dv. Here on the LHS we have to integrate with respect to t, and here on the RHS we have to integrate with respect to v. Okay, so it can further be written as a dt, integration of dt. Let us consider initially the time was 0 and it went up to time t, and here integration of dv. Let us consider the initial velocity was u and the final velocity was v. Now after that we can proceed it as integration of, this is a, integration of dt is t. Okay, integration of dt is t, and the lower limit is 0 to t is equals to integration of dv is v. Again here the lower limit is u, to the final velocity v. Okay, this can further be written as a upper limit minus lower limit, that is t minus 0 is equals to again upper limit minus lower limit, that is v minus u, which can further be written as a t is equals to v minus u. Therefore finally we get the equation that v is equals to u plus a t. So this is the first equation of motion which is derived by the calculus method. So let's move to the second equation of motion now. Now students, in the second equation of motion, okay, in the second equation of motion by the calculus method we will be discussing now. Now students, again we know from the definition of velocity that velocity is equals to change in position with respect to time, or rate of change of position. So here, which can also be written as v dt is equals to ds. Okay, now we can also write it as ds is equals to, from the first equation of motion, students, we have been knowing that v is equals to u plus a t. So we can replace v is equals to u plus a t multiplied by dt. Clear? So now this, if we write it after integrating it, okay, integrating both sides, okay, we get it is integration of ds is equals to integration of u dt plus integration of at dt. Now let us put the limits as well. Let us consider the initial position was at 0 and it went up to s, and in here we have to integrate with respect to time. Let us consider the initially the time was 0 and the final time was t. Here also we have to integrate with respect to t. Let us consider initial time was 0 and it went up to t. Now, when we integrate it, what do we get over here? That integration of ds is s, that is from 0 to s, is equals to, on the right hand side, u is constant, will be kept out. Integration of dt is t, that is from 0 to t again, plus a is constant, and the integration of t is t square upon 2, and from 0, it is from 0 to t again. Now here the upper limit minus lower limit, that is s minus 0, is equals to u, and the place of t again it is upper limit minus lower limits, plus, sorry I forgot to write a over here, this is a. So a multiplied by upper limit minus lower limit, that is t square by 2 minus 0 square upon 2, which can further be written as, this is s is equals to ut plus a t square upon 2. Okay, now we get the second equation of motion, that is s is equals to ut plus half at square. So this is the second equation of motion that we have derived from the calculus method. So let's move to the third equation of motion now. Now students, in the third equation of motion, we have been knowing this already from the definitions, that a is equals to dv upon dt, and let us consider this is equation 1, v is equals to ds upon dt. Okay, now from these two equations, let us see here that we have been knowing that a is equals to dv upon dt. Now if we put or multiply both side by v, okay, so here we can replace v as ds upon dt. Okay, so it is ds upon dt is equals to, let us put v as it is already over here, v multiplied by dv upon dt. Yeah, dt gets cancelled. Now integrating both sides, we get integration of a ds is equals to integration of v dv. Okay, on the LHS we have to integrate with respect to ds. Let us consider from 0 to s, and on the RHS we have to integrate with respect to dv. Let us consider the initial velocity is u and the final velocity is v. Now here a is constant and the integration of ds is s from 0 to s, and here also let us consider that the v is integrated with respect to dv. So integration of v with respect to dv will be equals to v square upon 2, that is upper limit will be v and the lower limit is u, which can further be written as a multiplied by s upper limit minus lower limit is equals to, here we can write it as v square upon 2, that is a upper limit minus lower limit. Lower limit is equals to u square upon 2. Okay, now this can again be written as a multiplied by s is equals to LCM 2, that is v square minus u square. Now this is equals to, if we put this 2 on the left hand side, we get 2as is equals to v square minus u square, which is the third equation of motion. And here students, we have studied the third equation of motion as well with the calculus method. So now the video of equation of motion completes over here. In the first video, we have discussed the equations of motions from the algebraical method. In the second video, we have discussed it through the graphical method, and here we have discussed it through the calculus method. So the calculus method is important from the class 11th point. Okay, so that's it with the video. Thank you very much for watching.